Hey there guys, and welcome back. So it is finally time to go over the projects we've been working on the past 2 weeks. They're all assembled and ready to go more or less. So starting out with the easy stuff to explain, which is the stuff for the arcade stick, and then we'll move on to the mini CNC, which had a bit more issues, which is one of the things that slowed us down. Also, I've got a slightly higher angle today to try to compensate for the fact that a lot of this stuff is a lot bigger. So one of those things. Eventually, I plan on, one of the projects I wanted to do is get this thing on an actual stand like my mic is on, so that I can adjust it all over the place. I do have a decent setup. I'm happy with my setup with the lift pod right here and the above the table look down on top of the monitor rather. But this lift pod, honestly, it'd be more preferred if it was if it actually had some movability to it, if it had dimensions of freedom, so to say, which it does not have. I just put it in one place and then it stays there, and then if I need it up a little bit higher like right now, I stack books underneath it. So anyway, point being, we will start off with the flag since that's the easiest thing. So this is the banner flag that goes on the sliders. Pretty simple. You can see again yesterday, if you watched the Tooth and Tail gameplay, it was a little bit difficult to show you when I was trying to show the monitor, the monitor cam. But here you can see, it says unit, one of those things. If I have multicolor printing, which frankly I don't feel like investing in because I don't have very many uses for it, I would have done, the letters in a different color. The alternative is back to, I don't have a sticker printer, and I keep on thinking, since I keep on running into situations like the cover on this end, where a sticker would make sense. If I had something that print stickers, maybe I would put a sticker on front of here instead of doing the inlaid text. The third alternative for inlaid text that I've seen is actually epoxy, but for something like that, that is completely impractical. I have tried paint before. I have tried paint on this. That did not work out very well, at least not with the paint I was using, but maybe there's an alternative. So anyway, point being, this guy, it was pretty simple to create. One of those things, I normally don't do artistic things, and this is very minimally artistic, right? It's a spline line and then a couple rings on the top, so this is pretty close to the limits of my artistic ability at the moment, at least in 3D design world, at any rate. Regardless, this does, because it's an artistic print, not print well. This does need supports. I ended up printing it, the best way I could find to print it is actually like this. So print bed like here, and then on an angle, so the base actually is not flat on the print bed, it's actually angled like this. That way the flag is mostly vertical. That was the most important thing to me. And then I did supports from bed and added support enforcers on the crossbeam right here. That way the supports went up to the crossbeam and that's it. They didn't try to get all of the flag, because again, if I have the flag mostly standing upright, these overhangs are not that bad. As you can probably see, I really don't have any artifacting from the overhangs. So the overhangs were not a problem on the flag so long as it was printed like this. It was just a matter of this cross piece is obviously being suspended in space and therefore needing supports. And obviously some supports from the bed, because I'm printing the base at an angle like this. And the bottom of the flag needs support because it can't be printed again in midair. Wow. Okay. Don't know what I'm saying evidently. I did try, for the record, to print it flat on the bed like this. The biggest problem I ran into is because I was doing supports from bed. This flag, the front of the flag, when it's like this, actually overhangs the front of the base. I'm going to try to show you on this side here. Let me see if the camera can really notice it. It's hard for it to see on the camera, but this edge right here is directly above the base if you print it on the bed, flat on the bed like this, and therefore it doesn't actually put supports right here, which makes it fail. So that was the first time it failed. I tried again because I didn't know why it failed. So the first time I printed it, I went to work when I printed it. It came back and failed. I said, okay, whatever, printer just failed. It happens, no big deal. Tried to reprint it, and that's when I realized that this flag portion was not getting supports, because supports from bed couldn't get past this guy. One of those things, I could have added support enforcers to the bottom here, but since I had already printed the other one, the blue one, standing up like this, and it printed 100% perfectly, no problem, I said, you know what, I'm not going to worry about it. I'm just going to print it the way I know it's going to work and the way that I know it comes out nice, because again, this has a really decent finish. Like, it is very, very acceptable. And by very acceptable, I mean I don't actually see anything wrong with it. Like, even the parts where the supports had to go on the bottom of these rings right here really is not that bad. I mean, it's a hair just because, again, it had supports on it, but it turned out quite well. So since I knew it was going to print quite well at an angle like this, I didn't bother. Otherwise, the last thing to mention is on the blue one, part of the reason why the blue one broke, as I mentioned in yesterday's stream, was because the supports went through this little eye hole in the middle here, because I did it support enforcers across this whole entire crossbar. This one, I did not do that, which is why this one was a lot easier to clear the supports off of. Instead, I put 2 support enforcers, one on each end of the crossbar, and that was good enough. So yeah, that is the flag. I do want to go ahead and hop in here, or the banner, whatever I want to call it, just to show you. I want to hop back and forth between Fusion and this today, and the camera today. Whoops, close that, is what I meant to do. So here you go. Again, this is the 3D model design. Now, you'll see I created these as components in here. That was really silly. I should have just created them over here, but all that was is just a boundary fill, text, and then text from surface. See, text from object, and then -1 millimeter. So I just click the face and then hit -1 millimeter. It's very simple to do that. And otherwise, like I said, this design, as decent as it looks from an artistic standpoint, is really just, you know, one pole going up, the crossbars that you just saw there, and then once the crossbar is there in, I just put the rings up here, and then a spline line offset the spine line, and connected them. So one of those things, just did what looked good, and at that point, we'll just roll back here a second. You know, so that extrudes symmetrical from the center, and then one ring, mirror the ring, and we're good. Just connect it, etc. So that's all that went into designing this. Since I did this off stream, I wanted to go ahead and show you. And again, I should have done the words on this actual object, but that did not happen. So let us go ahead and close those out, and we'll move on to this guy. So hopping back to the camera, set this guy aside from right now. Hopefully don't break them as I'm throwing them over onto the side there. So this guy had some issues. Well, it had a issue. It had exactly one issue. It had 2 issues. I take it back. It had 2.5 issues. Okay, it had one issue that I needed to reprint for, a second issue that was right here and I fixed, and a third issue that was down here on the spring. That was the third major issue, but because of the issue on the spring, I will not be taking this apart right now, so you're gonna have to visualize. And again, I got Fusion up, so we'll go ahead and look at it for right now. So the first issue that required a reprint, let me go ahead and get the pieces. Alright, so first thing I did, actually there was a second reprint before, but it wasn't that big of a deal. So let's see. Yeah, okay. So I print this out, right? This is the first reprint. Now, you may notice something right here. Evidently, I was an idiot on stream and did not actually put the holes for the microswitch through here. These are the mounting holes for the microswitch, and I did not actually extrude them through. That was pretty stupid of me. The second problem, which I also could have fixed on this piece, but I ended up reprinting it anyway, is you'll notice that these rings go all the way to the edges. These are the mounting holes for the knob, for the handle shaft is what I'm calling it. Okay, they go all the way to the edge, but we've got this lip right here, right on the inside. So since we have this lip on the inside, they actually need to stop short in order to not go into that lip. So one of those things, I could have fixed both of these problems. I could have drilled out these holes for the micro switch, and I could have just taken my X-Acto knife and cut out some plastic around the edges here. And honestly, I think that one was fine. I think it was just these two on the sides that just needed to be trimmed down so that, like this right here, so that the lip around the front edge of the could fit. So anyway, reprinted it, got this guy, had the whole entire thing put together, and went to print the shaft. Now you may notice something about the shaft, and in fact I got a first version of this over here. Have you figured it out yet? Should be pretty obvious at this point. This used to be round, and I went to print it, and it's one of those things where my original idea was to print it straight up and down like this. And that is perfectly a-okay. Again, the bridging right here would have been fine. I would have just bridged on the inside here. This piece, because it's going on the inside, I printed in black, which is bad for show and tell. I know I normally don't print things in black, but because it was going on the inside of the shaft, you'd never see it. I decided to use some of the black because I have extra black at this point that now that I'm streaming, I don't use because, again, it's hard to see. So I've got like 3 spools of black I'm trying to find uses for because, again, I'm just plain not going to use them on stream because it's hard to show details on stream. Anyway, back to the point. The bridging on the inside here, the bridging for the wall on the inside, no big deal. That can bridge all day long. The big deal was that printing in this orientation means that when you grab the handle, you are actually shearing in the same exact orientation as the print. And that is a problem. So I stopped myself. I did not print the first piece. I said, oh crap, I really shouldn't be doing this. I don't want to risk it. I don't want to print a piece of this large and then have it snap and have to reprint it. Or even worse, have to do a redesign. So I'll do the redesign right now. So I went ahead and made this guy. While I was doing this redesign, I realized that my hole pattern, and let's hold on half a second, let me pull up the old design in Fusion just so that we can see it. The hole pattern on the previous version was very much different, and I think that was, let's see, that was a while ago. Wow, actually, hold on, what's today's date? Oh, okay, never mind. I haven't worked on this in a while because I was just waiting for the other stuff to print. Okay, let's see. I guess I will open this one, version 18. Let's see. Let me close this out. Nope, not version 18. Let's try a different one. Alright, there we go. Alright. So, let's hop back into Fusion so we can look at this. Alright, so that was the hole placement on the shaft before. When I cut this down to half, actually let me close this one out before I got myself confused. When I cut this one down to half, you will notice that these holes right here are below that halfway, and it's not even necessarily halfway, but below the cutoff point is where the holes are. So the holes had to move up, and the problem with the holes moving up is that these holes, how wide they are, determine the width of the whole entire box. So at that point, I had to resize the whole entire box. I had to change the hole placement inside the box. I had to double check to make sure that the mounting holes for the micro switch were in the right place. And then, you know, when we got down here to the bed, I had to make sure that, let me Control Z here really quick. I had to make sure that these holes were still okay because these holes were potentially going to run into any changes, you know. So I had to double check a whole bunch of stuff. Turns out not nearly as much broke as I thought might happen, which is good. You know, I didn't have to change so much. However, what I did have to do, and this is why I have a second of these black pieces, is, well, actually there's 2 things. One, these holes were extremely close, these mounting holes on the bottom here. Let me turn over here to try to get some contrast, you know, so you can actually see them. These mounting holes on the bottom are extremely close to the edge here, and it was actually very, very difficult. So I wanted to move those out a little bit to make it easier to mount it, which again was going to make this box bigger, but I did not make this box. I didn't print the new version of the box until I had this guy done. So it was not that big of a deal. The second problem, I was going to live with this, but because I wanted to move the holes anyway, I went ahead and redid it. You'll notice how close that peg is to the bottom lip. It's one of those things. I could have lived with it. I could have lived with it down there. The spring just would have been off center. But since I was already making the changes, I lifted that peg up. that peg was center on the circle is how that peg was defined. So when we cut the bottom off this guy, obviously the center is no longer there. Unfortunately, this peg did not update to be on the bottom because the bottom did not exist in Fusion. And Fusion doesn't know what to do with that bottom coincidence in the sketch, so it just left it where it was. So I realigned that bottom coincidence in order to move the hole up so that the hole was centered, so that the shaft, rather, the pin was centered on the shaft, or what remained of the shaft at any rate. So those were the changes on this guy and this guy. Again, you know, just basic changes there. Now, this guy, I knew it was going to be big. It is a lot larger for tooth and tail than I expected it to be, okay? I did not expect it to be this large. Well, no, I take that back. I knew it was going to be this large. I showed you in CAD, in Fusion, I showed you in Fusion a comparison of this to the joystick. I said, holy crap, this thing's going to be large. So I knew it was going to be large. It's a lot different looking at it when it's here in real life. Now, the fact of the matter is back to, if we make this, if we add a second one onto this side and make this actual, you know, motorcycle inputs, this is actually decent size. It could be a hair smaller, but honestly not by much. So this still functions, you know, this is still functionable at any rate. At this size, it's not that terrible. I will say that when I printed this out, I looked at the peg, the 3mm peg that was right here, and I said, holy crap, that is going to break, isn't it? And I was real careful. I did not break it while installing it. I got this spring attached and all that stuff. Now, instead, I broke it while I was pre-tensioning the spring. So I put the spring inside, right? And what you want to do when you want this spring back here, for a torsion spring, is you want to add some turns to it. So you want to wind it up a little bit. That way it's already under tension. That's what I was doing. So I pulled it out. Again, the spring is holding this hole right here. It is holding the outside face of this to the inside face of the shaft. So it goes through the hole in the shaft right there, which you can just barely see on the camera because, again, black. But if you see the blue showing up right there from looking through it, one end of the spring goes through there, the other spring goes through here. I tailed it through the other face right here. I just drilled another hole. I decided, I had said on stream, you know, I could do this any number of ways. I might glue it down. I might try to melt it into the frame. I decided this was the easiest way. It's just to drill another hole and just put the tail through. This way, if I don't do that right, what happens is it ends up slipping. So that is why I did that, especially because this is holding it inwards. Anyway, point being, getting off that tangent, while I had this pulled out and was spinning it to charge it up, I accidentally I didn't let go. I started bringing it back in while it was not quite past this lip right here, and therefore it caught the lip and it twisted and broke. So at that point, I had to actually take this thing back apart, which was a nightmare. I also found out that while I had pulled it out and twisted it, one of the loops, one of the coils on the spring, had slid off the shaft, which is a problem, and had actually twisted itself up. It had overcharged itself, so it didn't fit back onto the thing. I had felt that a little bit here, and honestly, from the looks of it, and this is why I'm not taking this back apart right now, you can see how much of a gap this is right here. This is not meant to be this wide, this gap right here. And I believe the reason is that I had another one fall off. So if I was to do this again, what I would probably do is I might change this out from just a piece of plastic to a bolt or something like that. And I might put a washer on the end after I install the coil. So once I put the coils on here, I might go ahead and put a bolt through with a washer in order to keep the coils from sliding off the end. That's probably what I would end up doing. Now, on the one side, on the downside of that, rather, is what I should say. Actually, you know what? The other way to do it, I take it back. The other way to do it is to have a mating piece for the handle. So the handle has a mating piece that sleeves through there. And the reason why the washer might be a bad idea is, again, I've got to stretch the coil in order to get this on here, right? So I want to stretch it out so that it pulls down. I want to pre-stretch the coil. Not just for the turns, but also because that helps suck it in. So probably the latter thing I said, probably the mating sleeve. That way there is no chance for the coil to slip off. But those are the problems there with that guy. That is what happened. Anyway, I drilled this out, and if this doesn't look, it's one of those things. I'm sure it's very difficult for you to see on the camera, but if this doesn't look like an M3, this is not an M3. Again, this was intended to be an M3, but I've got a little magnet on the side of my desk, okay? And the magnet on the side of the desk, I throw drill bits that I'm using on while I'm preparing stuff, you know, just as a holder. And I thought the only drill bit I had in about that size, I actually still have a 1mm right here, and I had a 6mm on the magnet. So I thought the only other one there, and I didn't really look, so I thought the only one there was an M3. It turns out it was an M4, and I just slapped it into the drill and went to town, because one of those things, you know, something broke and now you want to fix it really quick to get it over with. So that's why this ended up as an M4, because I accidentally drilled an M4 hole, tried to put an M3 bolt in there, and went, oh, that does not work. Now, all that being said, in future, if I do this again, if I make another one of these handles, I will design it with the captured nut and the bolt instead, just because, again, the risk of that breaking is just way too much. Also, if you hear some ringing, that is because I am dog watching right now, and it wants attention. And by ringing, I mean like jingling from the collar. So, I am watching my brother's dog right now, and it wants attention. Regardless, let's see. Anything else to say about this? I don't think so. Alright, there's one last thing to say about this. Is I'm using this currently on the... Actually, hold on. Let me back up. I just want to reiterate, because I brought up the whole entire motorcycle idea a couple times here. Again, in order to transform this from our current setup to a motorcycle setup, we would want this to be an analog input, which means that I'd need to open this up and rewire this from a micro switch to some kind of either potentiometer or the digital magnet, encoders, digital magnet encoders that I've used in the other projects. So we'd have to redo the guts on this guy, but it's not that big of a deal. I take it back. It's a little bit of a big of a deal, only because what we'd probably... there's a couple of ways that we could do this. Basically, we don't have a shaft running through the center here, so the easy ways of doing this are not available, which is just attach to the shaft and measure the torque on the shaft. We'd have to come up with a different design, but it's one of those things. I'm just bringing up. This would require a pretty significant design change in order to get from the micro switch digital input that we have right now and the analog input for a motorcycle. So anyway, the last thing that I was going to say is I did design this to sit on 2 pieces of extrusion. The biggest... Do I have it right here? Hold on. Let's see. I do not see it. I'm not sure where I put it, but the only drop of extrusion I have sitting around right now is about, I think it's 16 inches or something like that. It's relatively large. So that does not work with the way my arcade stick is set up right now, which is why I am only using 1 piece of extrusion. But the reason to bring this up is that it's really not doing that bad. I was concerned with just 1 piece of extrusion that this would be flexing way too much. It's not. It's doing decent. It's not that big of a deal. So that is everything for this guy. So now we can move on to the CNC. Half a second while I grab that. Clear off this table. Alright. Don't sit in my seat. Alright. So I considered moving the camera up at this point to be on top of the desk, but frankly most of the stuff you can see right here with the exception of the Z-axis, so I'm just going to start with the Z-axis and then we'll the C belt drive rather at the top modification I had to do, and then we'll move from there. The modification for the Z-axis at the top is actually the easiest fix I had to do, and that was, as you can see right here, I forgot to put the slot in. So these brackets that I'm using for the Z motor, they have slots through them. Obviously I can't throw a bolt through the bottom side here because the motor's in the way, but I was supposed to put a bolt through here. I forgot to extrude the hole through, so I just drilled it out with a drill and threw the bolt through to hold it down there. And again, that's everything at the top, so everything else is easy to see on camera at this angle. And I like this angle, in case I didn't say that, because it's easier to see details as opposed to the monitor mount one, which is why I'm trying to keep to this. So, first thing is first. I printed... Let's get them all. This is embarrassing. This is embarrassing, but I printed a whole bunch of the X-axis, including this guy. So, I believe this... well, let's back up a little bit. The first thing that went wrong was that the bolt that holds these guys, the third bolt right here, the M4, that goes from here all the way through. There's one in the front too, but the one in the back, I had tangented to the front of this wheel, which means that'd be going right through the extrusion instead of the back of the wheel. So that was the first mistake. So that had to change, and that means that, let's see if I can find the one, because the one's going to be, yeah, it should be that one. So the Y-axis mount got a good bit longer. Whoops, sorry to hit the microphone. In order to accomplish that, because the M4 bolt had to move back, and then the motor then had to move back too, because the M4 bolt was then there. So that was the first change, and that was the first set of blocks. Let's see. I want to try to clear some of these off so that they're not in my way. So it looks like this guy. So these two guys was that problem. The next problem, which would be one of these two, I'm not even going to bother trying, is actually, I thought I had one more problem here, but it's hard for me to tell which one it is. So, oh, yeah, it's this one. Okay. So, I went and fixed that, and then I, because the way we designed this, and I said this while we were doing this design, I was saying with all the, I was saying it was better because Fusion does not have an alignment history, and therefore will not update your alignments when you make changes. I said, that may be a problem, but I hope it isn't. You may recall me saying that. As it turned out, that did end up being a problem, because after I made these changes here and extended everything out, the motor did not move with everything else. The motor did not slide back in order to accommodate this M4 right here. And therefore, I hooked this up. I put the wheels on it, hooked it up to the gantry, and then went to mount the motor. And the motor did not fit right in here. The motor did not fit in this slot right here. So that was problem number 2. You'll see we have a third problem here. Third problem here, and I actually was trying to fix this while I was doing the other two things, was even from the first one I knew that the way we were doing our tires was too far. It's one of those things I kept on overestimating. I kept on going, we have the eccentric nut, so it should be able to take up the slack. It didn't. It just plain was not enough. I need a lot of friction on this axis in order for it to actually function, especially because we're using a belt instead of a lead screw. And therefore I really needed these wheels to be tight, and I kept on trying to skimp on it. And what I ended up with, and I redid this while I was at it since I was redoing the other one of those things, the tool head also should be rather tight, and it was a little loose even with the eccentric nut turns. So I changed it to be identical to this guy, and the number I ended up with was 42 millimeters. And that, frankly, 42 millimeters between wheels. And that is a number I remember, and I'm pretty sure I've used that number a lot of times in the past. Again, it's one of those things. I was doing it based off of the CAD design. I was deriving it from the CAD design instead of just using numbers, instead of just using math. And that's just another thing that bit me, you know? So, had to print an extra 3 parts just to get this sizing right. From now on, I'm just going to do the 42 millimeters between wheels and not even bother playing around with anything else. Just leave it at that because that works. So that is that. The next thing to talk about is the base right here. I think. Let me look really quick. Anything else I had to change? No. Yeah, so that all worked just fine, and then I got down to the base. So let me grab those pieces. Oh, well, This was not a mistake. This is the Z motor mount. This was not a mistake. I was just doing a full plate of pieces overnight the very first time I printed it. So when I printed the first version of everything, I fit as much as I could onto the bed to print overnight. And this piece just failed. I actually woke up like an hour into it, noticed that it was failing. I pulled this piece of plastic off because it was completely janked up. Used a pair of cutters to cut the janked up piece off, and then actually applied the glue stick to the bottom and glued it back down in place. As you can see, it actually didn't turn out too bad. You can notice a very slight layer shift right here, back to one of those things. If I'm going to glue it back down, I'm not going to be 100% perfect with where I place it, but frankly, for something that was going to completely fail, it actually turned out alright. But I decided not to keep this. I decided to go ahead and just print a new one instead. Again, it's frankly decent enough. I could have kept it, but I didn't. So that is that. I'm just double checking really quick. Oh, there was one more thing on the Z-axis I totally forgot about because it was a quick fix. It was a quick fix, and therefore I forgot about it. You will notice that there are spacers, a bunch of washers, a stack of washers in between the motor bracket and the motor itself. And that is because the top thing here, the top motor, the shaft on the motor and the pulley, I said, it can be adjusted in and out, no big deal. So I stuck it a little too close. I put it at the farthest end. I should have put it at the closest end is where I really should have done. I should have aligned the pulley close to the motor and then said, okay, I can always adjust this out on the shaft if I need to adjust it out. I did the opposite, and unfortunately the pulley could only go just so far in and could not compensate. So one of those things. I actually haven't fixed that on the CAD yet. I probably should, just in case I ever need to reprint that part so that I don't end up with this problem again. But that is a problem for future me. So anyway, yeah, that is a very minor fix. Just stacked a bunch of washers in there to to move the motor back. Otherwise, it wasn't that big of a deal. No need to reprint the part. So anyway, the pulley block at the bottom here, the Z-axis pulley block. As you can see, we have quite a few of these. All right, so here's the original design. The problem with the original design is that it actually worked extremely well. I had no problem with it up until the point I went to put the belt on here. The problem was that, and actually I should have grabbed the pulley just so I could demonstrate. Let's see, do I have one in here? No. Where's my box? My box is buried right now. All right, never mind. The box of CNC parts, of V-wheel parts, belt parts, is buried underneath some other stuff right now, so I'm not going to grab it. The problem is, you can see, this is the orientation, exactly as you can see here, that it goes in. This is the orientation of the shaft, which means that the pulley is going this way. Round this way, which means that the gap is in the middle. The belt needs to be going this way. You will notice that the belt is running down this edge. Let me actually turn a little bit so you can see it. So the belt is running down this edge, which is exactly perpendicular to where it needed to be. So that was a problem. That required a redesign. So we did a redesign. We did a redesign, and let's see. Yeah, okay, so it is this guy. We redesigned it. As you can see, because I now, the reason to cut out these sides here, in case you do not remember, leave these cutouts here, was so that the bottom wheel could actually go down further than the mounting nuts. These are the mounting nuts for attaching to the Z-axis extrusion. So that would attach on the side there, and then the wheel right here, or well, the bottom wheel down here, but this wheel on the bottom would sit all the way down here instead of sitting above here. The second I turned this sideways, which is what had to happen in order for the pulley to be in line with the belt, well, now all of a sudden that wheel can't actually get down here, right? So that wheel can't get down that far. So at that point I just said, all right, in that case I'm just going to build out this whole entire square here, right here, and we'll be good. So I did that. You can see that this was originally 3mm walls on this side. When I built it out, I made it 6mm just like everything else. And that meant when I did this reprint, because these walls did not exist before, Fusion lost track of where it was at and lost the, what do you call it? It lost the constraints on these circles right here. And these circles are mounting holes on these mounting holes for the ring. And that means that they are way too close to the edge. I considered just living with it and decided not to. I decided it needed to be reprinted, that these nuts that are holding the tension ring, this tension ring right here. Let's see if we can get a better look. There we go. Cool. So this tension ring, these nuts that are holding it, I decided they really can't be that close to the edge. So I reprinted it. And the second problem showed up. Now on this guy, the extrusion fit down here just fine, and it fit only as far as it needed to. It just fit to the bottom of these holes right here for the T-nuts to grab, so just to the bottom of those holes. And that was a-okay, hunky-dory. The problem is that now the extrusion is completely enclosed in here, and I did not set any offsets for my 3D printer. Again, my 3D printer does not print 100% perfectly, which means that I tried to stuff the extrusion into this guy, and it did not work. The extrusion could not get into here. So I reprinted it with the 0.1 offset. I went 0.1. I did not go any bigger than that because I wanted to be just a hair looser than the 0.05 that I normally use. But I did not want it to go so loose that I had any worries that the Z-axis would be wobbling. This wobble right here is only because of this piece right here not being perfectly rigid. So this is not actually wobbling inside of this guy, inside of the pulley block. So those were the changes that had to happen with this. Those were problems that honestly shouldn't have been overlooked. So for example, this guy right here where they printed too close to the edge, I should have given this a good look and said, oh crap, because I thickened up these walls right here and these walls did not exist, I should have double checked that everything else was properly restrained. I did not do that. That was a mistake on my part. And then with the offsets for the extrusion, it's one of those things, that's something that actually should have been in there from the very beginning. The inside offsets should have been in this model right here from the very beginning, and therefore probably wouldn't have been as big of a deal, but they weren't. And again, that was definitely my mistake right there on doing that. So that is all those pieces. The last one to talk about is this guy, which is just the fact that, again, I thickened up these sidewalls. I take that back. Hold on, anyway, I thickened up the walls, which means that this piece actually got a bit larger. It got larger by about 3 millimeters, so I couldn't reuse this piece. I had to print out the longer version to fit on here. So that was a very simple fix, not that big of a deal. Oh, actually, there is one more thing there. I realized before I printed the first part, so I caught myself early, but I didn't catch myself on stream. This was supposed to be a slot right here. I did not make this a slot, but again, I caught that before I printed it the first time, so it wasn't that big of a deal. I don't have an extra piece sitting around, fortunately, but that is something that I said I was going to do on stream. I said I was going to make this a slot, and I never did. The other thing, actually, now that reminds me that I did not do on stream, was I said that, oh, that'd be a nice idea to have slots on the back of this X gantry to slide the belt through to tie it off. One of those things, rather than reprint a fourth version of this with these slots on here, which I did not want, because I didn't realize until I actually put the belt on here, and that happened after I got down here to the pillow belt. So this was rather late in the situation here. I just took a 3mm drill bit, drilled a bunch of holes, and then cut them out, just reamed it out into a slot for the belt to come through. Now, that does bring us on to the next thing. I said that I wasn't really sure how I do this. I have several options. I decided to try this one and see how well it works. And frankly, so far, it seems to be working well on all three axes. And that is, I just used hot glue. And I know for a fact that this is working well because, again, not again, actually. After I finally got this belt in here and tensioned, I found that it was actually did not have nearly enough tension. So I found that simply cutting this off, cutting the original piece, sliding my X-Acto razor, where's it at? Should be right here. There we go. Yeah, just taking my chisel razor and going underneath here, prise the glue up, and then I just pulled it out to get the extra tension out. One of those things, untension this ring down here, untension the ring right here, cut the glue. Let me move this back a little bit because we're not on this side of the machine, we're not getting terribly much light, so let me try to improve our situation a little bit. Anyway, just pried up the glue, peeled it off the belt, and then pulled the belt and retensioned it. So again, this glue right here, the hot glue, actually works well enough. I was interested to try it because it's an alternative. My other two alternatives is I could have printed little belt clips to keep them in place. That would have been an easy alternative. Or the third alternative is I have little nickel strips that I think I've shown you guys before. I'm pretty sure I've shown you guys my little nickel strips. My third alternative was I was just going to take those and crimp them onto the belt. Easy enough. One of those things. Easy enough, but once they're crimped, then they don't work very well re-crimping. You know, if I needed to pull this out like I did. Same thing happened with this guy. So, the first time I put this together, which was before I realized there was a problem with the pillow block down here. Not pillow block, but pulley block. I could have swore I rode this back and forth testing things before I put the belt on this guy. And I could have swore that I did not run into a problem. However, after I got the belt on here, I realized that, you see this piece of extrusion right here? The Y axis, the bed. There we go. I'm trying to say the Y bed is what I was trying to say. But the Y axis, which is the bed, the bolts I have running through here are M5 by 40s. I needed M5 by 35s to be more correct. That would have been the size that I actually needed, was 35 millimeters long. I do not have 35. I have 30, 40, 45. And I think I might also have 50, but anyway, I obviously skipped the M35s, which means that these guys were a hair long, and that only became a problem because these feet are only just so long, and this extrusion is sticking out. So had these feet either been a little bit taller, which I don't particularly want to make the feet any taller than this, or I had cut this back extrusion down to be the proper size. I didn't want to do that because one of those things, if I ever take this apart, I prefer to have as long of a piece as possible, and it's not hurting anybody, with the exception of running it to the bed, being underneath there. So I took a cutoff wheel for a Dremel and cut my way through there. I do not have a hacksaw. I do not have a... So I got myself a jigsaw. I want to set up a jigsaw jig, frankly, is one of the projects that I was going to show you guys when I got it set up. I have not done that yet. I didn't want to design it on stream because it's so stupid simple that I didn't want to waste a stream designing it. But I don't have that set up at this point, and I don't have a bandsaw. I don't have a vertical bandsaw to cut these bolts on. So I used the cutoff wheel, went outside, because frankly these cutoff wheels on the Dremel make a huge amount of dust, which is really annoying. The cutoff wheels at work that I use with the grinder, frankly, do not seem to make nearly as much dust as these guys do. I don't know if it's because these are much finer and therefore they're creating much finer grit. That may be it. I don't know. I just know that these things for the Dremel seem to be a heck of a lot dirtier than the full-sized ones for the grinder. And I'm just complaining right now. So anyway, I took the bolts, just cut 5 millimeters off them. I actually did it on the bed because I didn't want to take the bed apart. Again, these are hot glued in here. If I used 3D printed grippers, this wouldn't be as big of a problem. I could have slid them off and then taken the bed off and then done it with just the bed, or taking the bolt all the way out. That was another option. I did not feel like doing that, so I just took the Y-axis out by itself, cut them down, and then put them back on. So that is all the troubleshooting I've done on this guy. The next thing to talk about is electronics. So I intended to do a demo of this while we were here. I had Marlin completely built, and in the course of doing the configurations on Marlin, one of these things, I have extra Melzi boards. I have, again, this guy is going to be using, one second. Whoops, Piper. Piper's the dog. Piper was sitting behind me. So I have this off my Ender. I just stole this off my Ender as the power supply. And then this was the old board that was on my Ender. This is the silent board. So I had this guy sitting around, and my intention is to use this guy for the mini CNC. And I was compiling Marlin, got it compiled just fine. While I was compiling it, though, I noticed that it had an option for a 16x2 LCD, which I've got many of. This is a little breakout board I made, so I've got a jumper down here for the backlight on the bottom there. I don't know how easy that's going to see. So to the left, between the board and the ribbon cable, you'll see this little jumper down here. So I put a jumper in there for the backlight, and then obviously I have this ribbon cable right here. I have this extra purple guy on here because sometimes I can be really frugal and decided to leave it on there just in case, and that was kind of silly and frankly looked like trash. So that is no longer here. So anyway, I got this jumper right here, and again, it's just a breakout board for testing. One of those things I can go ahead and pull this LCD off in case I need it, in case I need to put a new one on here because this breaks. I did it all in headers, so it's a really convenient thing to have. I wanted to use this. The problem is that I could not find nearly enough documentation online over the past 2 days to actually get around to doing this. I did a bunch of searches, okay? A bunch of searches trying to find a pinout for the Melzy board, okay? And it's one of those things you can find pinouts. Let me put this over here so that it's actually in screen. You can find pinouts of Melzy boards, just old-fashioned Melzy boards. My biggest problem is that I was pretty sure, because this is the LCD header right here in the front. In case you're not familiar, this guy right here is the LCD header. Normally that uses all the pins on the LCD. I did not want to do that because I wanted to use some of the pins on that header for other things. I wanted to be able to hook probes and whatnot into the mini CNC. So if I was going to put this on here, which I was only going to do for a demo, but point being is I didn't want to plug the whole entire ribbon cable in just to run this LCD. I wanted to do an I2C LCD, which is what this guy is. So we got voltage ground and then SDA, SCL, right? Serial data and serial clock, I believe is what those are. CL, yeah, sounds right. At any rate, I had a heck of a time finding the pinout for this header right here, this ribbon cable header. I did find it eventually this morning, and the place I found it, and the reason I didn't just give up is because I know I've found it before, because again, I've done stuff like this before, and I recall seeing the pinout for that header somewhere. I found it in the GitHub for Creality's GitHub, or was it Creality's GitHub? It's one of the things. It's the Melzy board pins.h. It's in pins.h. Actually, yeah, it's not in Creality. It is in Marlin. It's in Marlin's GitHub repo, and it's Melzy. I forget the whole name of it. It might be Creality Melzy pin as the folder, and then pins.h as the file. At the bottom of that has the full pinout, and it has all the pins for the micro processor right here. So, point being, I finally found that, but obviously that was this morning, and I was not going to troubleshoot doing this because, again, there is no documentation that I can find online to hook this up. So I'd have to do some experimentation. I want to get the video out. At any rate, frankly, this was not my end plan. My end plan was not to have this guy. Oh, the other problem, sorry, just a sidebar. The SDA, I believe it's the SDA pin that they say is on here, is actually listed as LCD button on the pins.h file. So evidently that was being used as the pot button, as the potentiometer button, the push button on the potentiometer. That seems like, that sounds to me at any rate, that's going to cause me some problems if I try to take that over. Plus, if I'm going to demo this, the point of demoing this with an LCD screen is in order to use the SD card in order to run files, right? So if I can't actually interact with the SD card because I no longer have the potentiometer button in order to select stuff on the menu screen, you can see how we run into problems here. Now, the fact of the matter is that this is all pretty mute because, well, it would be pretty moot because my uncle handed me a couple of phones, and what I actually want to do is not use this LCD as great at all. I actually want to try running it off of the what is it called? Octopi OS, whatever the heck the Octopi OS is called. I saw that on Tom, I'm going to butcher the last name, Sanaladerer. I think it's Sanaladerer is his last name. I saw him demo it once, and I've been interested in doing it since then. I just don't have the last phone that I have that is available is actually a Droid Bionic 2, which is super old, so I wasn't going to bother trying that. But now that I have some new phones from my uncle, I actually want to try to run this off of one of these cell phones. Sorry for the noise. So that is actually the end goal. The end goal is not to use the LCD. However, I bring all this up because since the documentation on a 16:2 LCD is so freaking poor on the internet right now, I actually do want to troubleshoot this. I actually do want to get this set up and working so that somebody else, again, it's not going to be me because I want to use a cell phone instead, but somebody else, at least if they want to use a 16:2 I2C LCD, will know how to do it. Now, do those people actually exist? I don't know. It's just the information is not in the internet, and that bothers me. So I do want to investigate using one of these guys. Again, I have pots with buttons on them, so I'll just hook a pot up with a button and then figure out how to reprogram the configuration in order to use that. But anyway, yeah, so that is that deal. That is why this is not hooked up and running right now, is because I ran into all those problems with the LCD screen. I didn't have an LCD screen that I could just slap on here and then run a test G code off of the file. And yeah, so that is that. So the next time we talk about this program, I will hopefully have this guy set up, and then we can talk about the changes I made in config/advanced config in Marlin. I guess the other thing I should say is I am using Marlin specifically because I have the silent board. I already know that the Marlin runs on the silent board. I don't want to mess with putting Gerbil on the silent board. I have run Gerbil off of, I'm pointing over here, but this over here is not actually a Nano. That I'm pretty sure is a Micro over there, but I've got a Nano around here that I have run Gerbil off of before. So I've done it before. I could run Gerbil, but I ran that Gerbil with actual stepper drivers, like actual big box stepper drivers, instead of these little TMCs that are on the silent board. Point being is that this is set up for Marlin. I'm going to use Marlin on it instead of Gerbil. So that, I believe, is everything. That is the plan moving forward, is to get this guy set up with the LCD just for a demo, just for documentation on how this works. Because in theory, again, advanced config, I'm pretty sure it's advanced config. It might be regular config, I forget already. But it says it should work. It says generic LMC, which it's LMC 1602, which I'm pretty sure is, or LCM. So liquid crystal matrix. I'm guessing it's liquid crystal matrix 1602 is what we got right here. And then it is under the I2C setting, which this is the I2C shield right here for this guy. So in theory, this should work. It's just, again, first problem is actually making sure that it works, because I can't find anybody saying they've ever done it online. And second problem is, again, the SDA, I'm pretty sure it's the SDA pin on this header down here is actually supposed to be for the push button. So that conflict sounds like it's going to show up to me. So that's where we're at. Let's see, 4 other projects. I keep on saying I'm going to make a decision on the Stream Deck. We are going to do a redesign of the Stream Deck. However, I did mention that I did something really cool with the Stream Deck, involving the Stream Deck, that I was really excited to share with you guys. I'm going to do one more demo piece to show alongside that. So I'm going to show you what I did with the Stream Deck, and then I'm going to do another demo piece to further accentuate what can happen. So that is going to be its own video, just demoing this process that I'm working on right now. And then the other video will be us actually modifying the Stream Deck to better improve the slides. Again, the Stream Deck right now, let's see, move this out of the way. So this is the bottom half of the Stream Deck. Again, I did put it together, and the problem is that these slides are just really the heck janky, and I don't really like them. They technically work, it's just it's not usable on a practical sense. So I really do think, so you can imagine me being over here streaming, right? And the point is that I really quick, if I need to move this out of the way, get down to a button right here, you can see how difficult that is already, getting this slid in and out. Now, it's not that big of a deal if I always keep it out, You know, it frankly, I can push down on this pretty darn hard, and you can see it's not, you know, breaking. It's not breaking. It's bending a little bit, but it's not that big of a deal. It's just the point being, and you can see how this also cants. Now, again, this does not actually matter, this canting right here, just because in theory it's, you know, if I'm doing this all the time, it shouldn't really be a problem at any rate. It's only going to be a problem if I'm doing weird things. My point being. So technically, this setup does work. It's just, I really don't like how poorly this slides. Technically works, just not acceptable in my opinion. It needs to slide better. And again, the reason we have it set up like this is because I was trying to keep this as narrow as possible. Where this is at right now in terms of width is, honestly, I'd like it if it was this wide, but at this point, it could be a little bit wider. I will accept it being another, you know, 6 millimeters wider on each side if necessary in order to have a better sliding system right here. So we will come back, redesign this. We should be able to salvage most of this. Like, there's no real reason why the tilt base shouldn't work. The tilt base, it has its mounting holes, right? We can keep those mounting holes in the middle of the board and then just, you know, widen it out. The tilting base does not need to be the full length of the board, technically speaking. So I can save that myself, although I'll probably update the CAD so that it is the full size for anybody else who wants to print this out. But for the time being, for me personally, I'm not going to reprint this piece just because it doesn't line up to the out that we end up with. So that's where we're at with this guy. Otherwise, again, now that I have the arcade stick set up, I will be playing some more Tooth and Tail. Again, not completely sold in the game, but we made a stick for it, so may as well play it. And other projects. Let's see. Again, the epoxy project is waiting on this guy to get set up because I would do fun probing stuff with that for fun. So I just put that on the back burner. And we also don't have any need for the conductive epoxy just yet. So one of those things, it can hang out. It doesn't need to get done right away. Let's see. I know I'm forgetting something. Let me look at Fusion really quick. I know I cleared out my recent files because I had a you're at your max edible alert. Let's see. For the arcade stick, you'll notice when you see me playing Tooth and Tail that I've got a bit of a rat's nest, ironically enough, with the wiring. I do plan on doing something with that. I'm in between extrusion covers, so running the wire down here, kind of like this belt is, and then covering it up with an extrusion cover. I'm between that and just getting clips and just putting clips on top. I consider designing my own, and then I decide that's just kind of a waste of time. There's like 1.5 million designs for cable clips for extrusion, so there's really no need unless I come up with one of those things. As always, if I come up with a cool idea, then I'll do it. But I am not feeling especially inspired on that guy, so I am not. I feel like it's one of these funny things. Actually, you know what? Let me hop over to YouTube really quick and check, because I could have swore I've had so many projects going on that we just wrapped most of them up that I'm probably just getting myself confused here. But oh, the animation program. There we go. I knew there was an important one that I wasn't addressing. Yeah, the animation program. So the animation program, again, a refactor is going to probably have to be necessary on our code. And by necessary, I don't necessarily mean absolutely necessary. It's just, it makes life a lot easier if we refactor it. It's just going to take a bit of time. And because we've never refactored, done a proper refactor of code, especially now that I have unit testing in place, it makes sense to do that live on stream. So there is that. Otherwise, I guess the other thing to mention is with the arcade stick, I was not able for Tooth and Tail. Tooth and Tail is only working right now with the arcade stick because I'm using the 360, what is it? XC360, XCE 360, Xbox Controller Emulator 360. There you go. I think that's right. Or maybe it's X360 Controller Emulator. One of those two, whatever. I'm using that program right now to run it. The game did not actually recognize my joystick, which I was a little surprised at, but it did not recognize my joystick, so I'm running that through an emulator right now. I had mentioned before that that's something I'd have to do potentially in the future. This is the first instance of that. So, the other interesting thing that I'm considering with this guy is I actually found out that Marlin does have joystick availability. It does have an option to use joysticks with Marlin. So I'm considering hooking our extra joystick that I bought for comparison, hooking that up to this guy. So that's an interesting idea. If I end up getting that working, I will go ahead and let you know. Otherwise, I'm scrolling through YouTube and nothing else is sticking out to me. So one of those things at this point, because I can work on this guy, getting this guy up and running in the background, we can start streaming some other stuff at this point. Again, we'll have the Stream Deck as an option. But aside from that, I think we can move on to some new projects. Stream Deck and the Stream Animation program, I guess, are two major ones that we need to be working on. Otherwise, yeah, new projects probably. So look forward to that. And yeah, I think that's it for me. So let me just double check behind me. Anything else back here? No. All right. Yeah. Pretty sure that's it for me. So thanks for watching, and thanks for hanging out with us with all our projects. We got major projects done this week, with the exception, obviously, with the electronics here. This still needs to be sorted out, but otherwise, we are making good progress on that. And yep, that is everything. So I think I've been about 20 minutes outroing here. It should be about right. So as always, I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.